Earth's rotation speed is increasing. What is going on?
So, how long does it take for Earth to rotate once on its axis? We call that a day. Add up all the seconds and minutes, and the 24 hours of a day equals 86,400 seconds. If Earth is your only measure of its rotation speed, how would you know if it's changing? You need another timekeeping device. Not only more accurate, but also more sophisticated than Earth, to have any clue about changes in Earth's rotation speed. This began in the 1950s when we introduced the atomic clock. Atomic clocks keep time using vibrations within atoms, unrelated to the sun, moon, stars, or Earth. It keeps its own time. When we started carefully recording the passage of time by the atomic clock and the Earth's rotation speed, we noticed a difference. And from the early 1970s, we began compensating for that difference. In most cases, Earth is slowing down, so we add 1 second, called a leap second, to compensate for that delay. Another way would be to change the definition of a second, so that 86,400 seconds still make up a full day. But that's too complicated, and modern society is not ready to accept that. The duration of a second is precisely defined, and we will add or subtract a second as Earth deems necessary. When do we do this? By official decision. There are 2 points in the year, the last minute of December 31st. That minute will have 61 seconds, or the last minute of June 30th, which will also have 61 seconds if needed. Since 1972, when we had sufficiently accurate atomic data up to the latest check, we've accumulated 27 leap seconds due to the gradual slowing of Earth's rotation. This monitoring is done monthly, weekly, and daily to see how the accumulation trends. Earth could also speed up, and we have a mechanism to handle that too. If Earth speeds up by a full second, we'll remove a leap second at one of those 2 time points. That minute will then only have 59 seconds instead of 61. All of this happens under the hood. Your computer will know, but you don't have to, because adding or subtracting a second or millisecond each day doesn't really affect anything. I mean, you probably don't live down to the millisecond anyway. I'm just assuming that about you. Many factors affect Earth's rotation speed. The most important among them is the sloshing of ocean tides around continental shelves, mainly caused by the moon. So Earth and the moon are like performing a dance when the moon causes the tides. The tidal bulge on Earth actually makes the moon speed up in its orbit, forcing it to increase its distance from us. So the moon is truly spiraling away from us, not by much, just a few centimeters per year. How do we know that? We can calculate it based on this dance.
In 1969, Neil Armstrong and Buzz Aldrin placed these corner reflector devices. Any light hitting them from any direction will bounce back exactly parallel to the incoming direction. You shine a laser from Earth using a telescope, measure the return signal and time, and the result confirms that the moon is spiraling away from Earth as it has been for billions of years. The moon used to be much closer and much bigger in the sky. That's one of the causes of Earth slowing down. Other factors can also slow or speed it up, like earthquakes, continental drift, changing the distribution of mass on Earth's surface. You might say, but it's still a sphere. Not quite. Imagine a figure skater. When their arms are extended, they spin slowly. When they pull their arms in, they spin faster, because the mass is closer to the axis of rotation. When you pull mass closer to the rotation axis, you speed up based on the law of conservation of angular momentum. Conversely, when you spread mass farther from the axis, you slow down. Other scenarios like animal migration also impact rotation speed. North-south migrations move mass closer or farther from the axis. For example, moving toward the equator slows rotation, and heading to the southern hemisphere speeds it up again. Other factors include melting ice at the poles, not just Antarctica but also Greenland,
When ice melts during episodes of climate change, the water flows into the oceans, altering the mass distribution on Earth's surface. Anything moving from the poles toward the equator slows Earth's rotation. Yes, climate change is one of the forces slowing Earth's rotation, and so is Earth's liquid core. Heat from the planet's formation and radioactive decay has melted the core, allowing it to move and generate a magnetic field. Movement of conductive metals inside the core shifts the mass. All these phenomena can either increase or decrease rotation speed. The impact is very small. Milliseconds, fractions of milliseconds, very little. Some recent headlines say Earth is spinning faster and we don't know why. It's mysterious. Really? I call that clickbait. Not knowing why something happens doesn't make it mysterious. For example, you own 3 dogs, go out for dinner, and come back to find pee in the kitchen. You don't know which dog did it, but it's not a mystery. Likewise, not identifying the exact reason Earth spins faster on one day than another doesn't make it mysterious. It just means we need to check all known factors. Could there be factors we haven't considered yet? Maybe, but unlikely. We've studied this for over 50 years. The universe is full of mysteries, don't get me wrong, but the forces affecting Earth's rotation are not among them.
This is monitored daily. We compare Earth rotation to atomic clocks every day. And we know these values, very small, often canceling out day to day. Of course, there's a day in the year with the biggest shift, and people make it into the biggest headline of the year. But every year has a biggest shift, in both directions. Someone realized that and turned it into clickbait, and that's what we're seeing now. So rest easy tonight, or any night. Daily changes in Earth rotation, as I said, only matter once they add up to a second, and then we add or subtract a leap second. And you probably don't live or operate down to the millisecond. Just imagine we are standing on a spinning planet, orbiting the sun like a twirling dancer in a cosmic ballet choreographed by gravity. Until next time, keep looking up. New discoveries may shake up everything we once believed. Data suggests that dark energy may be weakening, meaning the universe could be expanding slower. If true, that would challenge one of the biggest assumptions in modern physics. But before rewriting textbooks, we need clarity. That's exactly why Star partnered with Ground News. They've built an app and website that helps separate hypothesis from science. With one swipe, you can find original research and highly credible sources covering the most complex breakthroughs in cosmology. They were founded by a former NASA engineer with the precision you'd expect from space missions. But the best part, Ground News isn't some new tool to learn. It's a smarter, better version of how you already stay informed. Follow every major development, from dark energy to deep space, through topic pages tailored to your interests.